Welcome to part one of our next discussion on key concurrency and scheduler operators that are defined in the context of RxJava's observable class. These operators are arranged to run other operators in designated threads and thread pools. And we'll be talking here about the subscribe on and observe on operators from RxJava's observable class, as well as the new thread operator defined in its schedulers class. Let's start with a discussion of the subscribe on operator. This operator can arrange to run the subscribe, request, and onSubscribe methods on the specified scheduler worker. This worker is passed as a parameter, which indicates which thread to perform the operations upon. It returns an observable that is requesting the asynchronous processing be performed. The semantics of subscribe on are a little bit unusual, so let's talk about them. In particular, placing this operator in a chain of other operators impacts the execution context of the subsequent on next, on error, and on complete signals. We'll talk about this in more detail when we get to the case study at the end of this lesson. But for now, if you take a look at the code snippet on this slide, by placing the subscribe on operator where we do and passing in scheduler's new thread, that will then run the range operator, map, do on next, and subscribe in the context of the new thread. Interestingly enough, we can actually move subscribe on later in the chain and have the same effects. So it doesn't matter whether it goes here or goes later, we'll have the same behavior. However, if an observe on operator were to appear later in the chain, that could change the threading context where the rest of the operators in the chain below it will execute. Keep in mind that observe on can actually appear multiple times, as we'll talk about here shortly. Project Reactor has a Flux class whose subscribe on operator works essentially the same as RxJava's subscribe on operator. Let's now turn our attention to the observe on operator in RxJava's observable class. This arranges to run the on next, on complete, and on error methods or signals on a supplied scheduler worker. As before, this scheduler parameter indicates what thread to perform the operation upon. Once again, what's returned is an observable that's requesting asynchronous processing. Mercifully, the semantics of observe on are a little bit more straightforward than the ones for subscribe on. In particular, it simply influences the threading context where the rest of the operators in the chain below it will execute, up to a new occurrence of observe on in that chain if it occurs later at all. We'll take a look at this example also when we get to the case study at the end of this lesson. And again, you'll see that we're going to be emitting a bunch of big integer random numbers in a background thread and then checking to see if they're prime. Project Reactor's Flux class has a publish on operator that behaves the same as RxJava's observe on operator. For some reason, they have different names, but they do essentially the same thing. Let's now turn our attention to a key scheduling operator for the observable class, or used in the context of the observable class. And that would be the new thread operator defined in the scheduler's utility class. This operator creates a new single-threaded scheduled executor service on each invocation. Keep that in mind. Each invocation will return a new single-threaded executor service instance. It returns this shared scheduler instance that can be used, or that does, create a new thread for each unit of work that's being given. This thread that's created is not reused, so it's only intended to be applied in very limited circumstances. Here's an example that we've looked at, and we'll talk about more when we get to the case study at the end of this lesson, where we are going to be generating some numbers from 1 to some max, and we're going to be doing this in a background thread as indicated by scheduler's new thread, which is the factor method that we're calling here, to emit the random big integers in a new publisher thread. When the work is done that the thread is processing, the thread will be automatically terminated. Project Reactor has a scheduler's utility class with a new single method that's very similar to the one that we have here for new thread in RxJava. The difference, however, is that the particular scheduler method that's called new single will return something that has to be properly disposed of, whereas the one that we have for new thread for the RxJava schedulers doesn't have to be disposed of explicitly. It's implicitly disposed of. So that's the end of our discussion about key concurrency and scheduler operators in the context of RxJava's observable class.